I hope that you are good, well, and fine. Today we will be starting Determinants chapter. Okay, chapter 4, class 12. Okay, in this chapter we will be seeing the introduction, and then we will be seeing determinants as a function. We will see some remarks, then how we defined determinant on matrix of order 1, 2, and 3. Some remarks on the basis of these definitions, and we will do some examples to get familiar with determinants. Okay, let us move to the introduction part. So first of all, every square matrix A, okay, every square matrix A of order n, we can associate a number. So this number can be real or complex. Okay, and that number we will be calling it as determinant of the square matrix. As you can see, by definition we are describing our determinants can be of a square matrix. This means what? By definition, square matrix will have determinants, other matrix won't be having determinant. Okay, this must be clear to you now. So how we are going to describe that number, you will see later. Okay, so far I hope that it is clear now that what is determinant mean to you. So determinant is just nothing but if you are having a square matrix, then you can associate a number to that. Okay, and that number will be unique, not what? It will be unique. Okay, so unique in the sense, if you are having a matrix A, if you are having a matrix A, this means determinant cannot be the matrix A, or a square matrix A cannot have two numbers associated with this. Okay, this cannot give you two outputs. Okay, this will be having only one output. Okay, if you take analogy from the function chapter, you all know that in function we describe that the output must be unique. Okay, you won't be having this x associated with two outputs. Okay, clear? Okay, this is what happening in determinants. The number we are going to associate must be unique. Okay. Now what? So it is clear that if you are having a square matrix, then only you can associate. By definition, we describe our determinants. Okay, now M is the set of a square matrix, K is the set of numbers, real or complex, both. So F is a function from M to K. It is defined as F. Domain is set of all square matrix. So input is matrix and the output is going to be K. As we are defining our function, that means the all property of function are going to be satisfied. So this A is associated with to some number K. This some number can be complex or real. Okay, clear? Okay, and that this K, or in other words this F of A, will be what? Our determinant of A. Simple. And this will be denoted by this two lines. Between two lines we will denote A, and do not confuse that it is modulus, it is determinant sign. Okay, determinant A or det A or this delta symbol, determinant A. Okay, if A is this means the determinant of A can be written as like this: determinant of A, in other words determinant of A, in other words determinant of A. Okay, and by definition it is clear that first of all, don't confuse with this determinant A with modulus A. Okay, this is determinant A, and only square matrices will have determinants. By definition we describe that for determinants or for association we must require square matrices. Okay, now what? Now now we will see how we described our determinant of some specific order matrices. Okay, so if you are having a matrix of order 1, then the determinant of this matrix will be what? So that A will be just this A, whatever the entry A. Clear? So this simple. Okay, now let us move to the next. What about order 2? If you are having order 2 matrix, means this 2 cross 2 order A11, A12, A21, A22. Then you will have your determinant A, notation will be these. Okay, will be multiply these. Okay, first of all multiply these and multiply this, then write and then subtract. So multiplying this minus multiplying this thing. Okay, I hope that it is clear. Simple to remember. What we did is quite simple. So first we took this diagonal entry, these diagonal entries, okay, and then minus these diagonal entry product. Simple. So for example, 1 2 2 1 is given, then the determinant will be, the determinant of this matrix will be what? Determinant of this matrix will be quite easy. So first of all, product these diagonal entries, you will have 1, and product these diagonal entries, you will have 4, and put the minus sign in between them. You will have minus of 3. Simple. Let me give you another example. So 6, 8, and 10 and 9. Okay. So multiply these, you will have what? 54. Multiply these, you will have what? 80. This means minus, and this will be what? As you can see, this will be what? 20, 20. This will be 26, I think. Yes, this will be 26. Okay. Clear? I hope that it is clear to you how we defined determinant in two matrices, 2 cross 2 matrices. So let me give you one question for you so that you can get what is happening. So please solve this. 10, 1, 2, 20. Please solve this. Okay. So multiply this, you will have 200. Multiply this, you will have 2. Put minus, you will have determinant equal to 198. Okay, simple to solve. I hope now you are familiar with this definition of determinant in 2 cross 2 matrices and also in 1 cross 1 matrices. So pick these, multiply these, and pick these, multiply these, and put minus sign in between them. Okay. Okay, let us move to next. Another example is given. So multiply these, what you will have 4. Multiply this, what you will have minus of 4. Now we already have minus in between them, so this will give you 4 plus 4, in final answer will be 8. So determinants will be 8. Okay, determinants will be 8, as you can see. Okay, simple. Now for this, multiply these, you will have x square. Multiply these, you will have x plus 1, multiply with x minus 1. Put minus sign in between. You, this is what? A plus b, a minus b. So this means I will be using formula. So x square minus 1 square will be 1. This can be reduced to x square minus x square plus 1. So this means the determinant will be 1. Okay, determinant will equals to 1. Simple. Okay. Now 3 cross 3, how we define 3 cross 3? Quite simple. So there are 6 ways to expand determinants of order 3 cross 3. How? Let us see. So 3 using rows and 3 using columns. Okay, you will see some of the versions of these. Okay, so first of all, determinants of 3 cross 3. So let us see according to the row 1. So row 1, as you know that A11, A12, A13, A21, A22, A23, and A31, A32, A33. Simple, clear? Now using row 1. So pick this entry A11, as you can see. Now what? By picking this entry, leave this row, first row and first column, leave this. Whatever you are left with, you will do, now you are only left with this thing. So this is what type of 2 cross 2 matrix. Yes, now find the determinant of this matrix. How you will find? It's quite simple. Just multiply this. So A22, A23. Now multiplying this 2, 3, A32. Now put minus, as you can see. Okay. Okay. Clear? Simple? Okay. Now what? Now pick this entry. Pick this entry A12. A12. Put minus sign always here. So minus sign with A12. Now what you will do? Remove this column and this row. You are only left with this, this, and this, and this. Yes, these entry you are only left with. Now what you will do? The same thing you found out just. So you will apply the same concept of finding the determinant of 2 cross 2 matrix. So this entry will be multiplied with this. So A21 multiply with A33. As you can see, A21 multiply with A33, and this will be multiplied with this, and this will be multiplied with this, and put minus sign in between them. You will get this. Now pick this one, put plus sign. So you started plus, minus, and plus. Okay, plus, minus, and plus. Now what you will do, as you observe the pattern, now the next step will be as very clear. So remove this column and this row. You only left with these entries. Now multiply these A21, A32, A22, A31, and put minus sign over here. Okay, clear? Okay. So in this way, you will define your matrix, sorry, determinants of 3 cross 3. Let me give you an example. Suppose 1, 2, 3, 2, 1, 1, 1, 6, 1. Okay, determinants of this matrix. So quite simple. So this is 1 comma 1. Okay, you do not have to remember the signs, that what sign you will choose. Quite simple. Or always do start from plus and then change the alternate sign. So plus, minus, plus. Okay, so plus, minus, plus for this row. Okay, for these. So you will use one, a plus for this one, minus for this, and plus for this. So this means start with this entry. Okay, you are starting with this. So removing this row and this column, you only left with this and this. Okay, so this means 1 multiply with 1 multiply with 1 minus 6 multiply with 1, 6. Okay, simple, easy. Okay, now choose this. So this means minus sign, so minus 2. So remove this row and this column, you will left with these entries. Okay, so 2 going to multiply with 1, so this means 2. 1 going to multiply with this one, so minus 1. Simple. Now we are having this, so this means plus 3. Now remove this column and this row, you are only left with these entries. 2 going to multiply with 6, so 12. 1 going to multiply with 1, so minus of 1. Now just simplify this, you will get what? So 1 minus 6 will be minus 5, multiply with 1, you will get minus 1. This will be 1, so minus 2, plus, so 11, 33. The final answer or the determinant of this 3 cross 3 matrix will be, as you can see, this will be minus of 7, and this will be 25. Okay, this will be 25, sorry, 26. Okay, simple. Clear? Easy? Okay, let me give you another so that you can get comfortable. Say 2, 3, 5, 1, 2, 3, 1, 6, 8. Or let me use just lower numbers. Okay, now just use sorry, plus, minus, plus, write these. So write these plus 2, minus 3, plus 5. Okay, now remove this row and this column. For this you will only left with, so 4 times 2, 8, 18, so 18. Okay, clear? Okay, now for this, leave this column and this row. you will left with these entries. So 1 going to multiply with 4, you will left with you will have 4. 3 going to multiply with 1, you will have 3 and minus in between them. Okay, now for this, leave this column and this row, you only left with these entries. Now 6 will be multiplied with 1, so 6, 1 will be multiplied with 2, you will have 2 and put minus sign in between them. You will have what? Simplify. Now simplify, you will have, and this will be minus of 10, this will be minus of 10, this will be 1, this will be 4. Okay, please do verify my calculations. If I am doing any mistake, please forgive me for that. Okay, now what, this will be minus 20, this will be minus 3 and it will be 20. Okay, this and this will be cancelled, you will only left with minus 3, so the determinant for this will be just minus 3. Okay, I hope that from these two examples you can get what is happening, how we define and how we are going to evaluate our determinant. Okay, along with the what, the first row. Okay, so this is by using expanding along first row. Simple. Now we will see what about if we use another row or column. So if you choose to use a second row, then what will happen? Quite simple. Let me write it here. So A11, A12. So let me just pick example directly. Let me pick example. So 211, so 212, 200 or 13134. Okay, so what about row 2? What about this row? So for row 2, if you remember, row 2 means 2 1 2 2 3. Okay, if you wonder how we came that we will use plus here, minus here and plus here, so this position is nothing but A11, this position is nothing but A12, this position is nothing but A13. Yes, so whenever you have the sum even, so here 1 plus 1 is even, here 1 plus 3 is even, here it is odd. So whenever you have the position, even position, okay, even, then you will use your plus sign, otherwise minus. Okay, simple, clear. Okay, so now you can directly answer what sign I will be using here. So as this is 2 1 position, means I will be using minus sign. This is odd, 2 plus 1 is odd, this will be even and this will be odd, so this means minus plus minus. Okay, minus plus minus. Okay, and you can also observe that if you just have to know this one sign and other sign will be alternate, so minus plus minus. Okay, simple. Okay. So this means, and from the formula you can also observe, so minus plus minus. Okay, so minus plus minus, simple. So this will be now pick. So first of all, what we will do, so write these, so minus 2 plus 1 and minus 3, simple. Okay, so what we will do, so the same pattern now will follows. So we will choose this minus 2, as you can see, minus 2, and leave this column and this row. So you are only left with what entries? You left with these entries. Okay, so this 4 will be multiplied with this 1, so 4. This 3 will going to multiply with this 2, this will be 6 and minus you will have, so 4 minus 6. Okay, now what, choose this, as you can see, you remove this column, remove this row, you will left with this 4, this 2, this 1 and this 2. Okay, now 4 multiply with 2, you will have 8. 1 multiply with 2, you will have 2 and minus sign in between them. Now choose this minus 3, minus 3. Remove this row and this column. You are left with what entry? You left, now you left with these entries. Yes, these entries. So this means now you will have 3 multiply 2 means 6. 1 multiply 1 means 1, minus sign. Okay. Now, as you can see, this will be minus of 2, minus of 2. This will be 6 plus of 6, and this will be 5, 5. Now, it will be plus 4, it will be 6, it will be minus 15. And in total, this will be, no, sorry, 10 minus 15, you will have minus of 5 as your determinant. So, the determinant for this will be minus of 5. Okay, I hope that it is clear. So, now if someone asks, what about this? Okay, if someone asks, what can you give me idea if you want to find your determinants along the expansion along with this row R3? So you can say yes. How? This pattern will follow the same. How? The first of all, you must know the sign. So this position is A31, means odd. Yes, sorry, even. Even means plus. So now your signs will be plus, minus, plus. Yes, sorry, plus, minus, plus. And you can also verify this position is 3-2. Yes, 3-2 is odd, as you can see, minus. This will be 3-3 means even, means plus. Now this can be reduced to plus 5, minus 0, and plus 1. Okay, simple. Now choose this, remove these, you will left with these. Same pattern. If you choose these, this entry, you will have to eliminate this row and this column. The remaining entries will be multiplied and subtracted here. If choosing this, will have to force you to remove this column and row. Okay, this column and row, you only left with these. Now you find your determinants of 2 cross 2 matrix accordingly. Okay, so quite simple. Okay, I have shown you the methods along the 3 rows. Okay, along the 3 rows. Now we will be seeing what about the columns. Okay, for columns, let me just quickly go through it. For columns, so columns will be same. So A11, A12, A13, A21, A22, A23, A31, A32, A33. As you can see, choose first column. So choosing first column means this. So choosing first column. So symbols remains the same according to the positions. So plus, even, odd, even. Okay, plus, minus, plus. As you can see, plus, minus, plus. Now what going to happen? So choosing this means you have to removing. You are going to remove these entries, means you are only left with these. So multiply these and put minus, as you can see. Okay, clear. Now if you choose this with minus A21, now you have to remove this row and this column. You only left with these entries, A12, A31, A12, A31, and A32, A21. Sorry, A32 and A13. Simple. Okay, so far so good. Now if you choose this entry, you have to remove this row and this column. You only left with these. So A12, A23, A12, A23, A22, A13, A22, A13, and put minus sign. So the pattern follows. Okay, so same pattern we are using again and again. Okay, now why I am, or why any book teach you these different types of determinants finding way. Why? As you will know, suppose you are having this matrix, okay, or just say 1, 3, or this. Okay, you are having this matrix. So if you find along with this first row, then you have to do this sort of thing. Yes, and then evaluate, then evaluate, then evaluate. If suppose you have to find according to the second row, then how will you approach? As you can see, the second row approach will be minus, plus, minus. Yes, minus, plus, minus. Now this means minus 1, plus 0, and minus 0. As you can see, this whole thing will be 0, this whole thing will be 0. Yes, and from using this second row expansion, you will have to just evaluate this thing. Okay, so this means this reduces your effort and the answer will be quick and efficient. If you perform these type of long run, then your what your percentage of making error will be greater compared to this. Okay, clear? You will do what, some calculative mistake? Yes, as you can see that you have, in finding determinants, you must have be very careful with the entries. Okay, so that's why we saw the different ways of doing or finding your determinants. Okay, so please choose the efficient way. How you are going to choose your efficient way? Whenever you see your entry 0, wherever you find your maximum 0 entries, please try to expand along that column or that row. Suppose if this happens, then you must choose this column too. Okay, then you have to just evaluate for this. Other entries, other thing will be eliminated directly. I hope that it is clear. You saw along with the first column, and the same thing will happen along with the second and third column. Okay, now, so the remarks and the some notes. So for easier calculation, we shall expand the determinant along the row or column which contain maximum number of 0, as you just saw. So while expanding instead of multiplying this, we just, as you saw that how we got plus minus thing. Yes. So we just added what, the according to the position, and whatever the position say 1 1. So just add these. You will have, if even, then choose plus sign. If you are having odd, then choose minus. Okay, clear? Okay. Now let us see some examples. So if A is this, B is this, you can easily verify that A is equals to 2B, as you can also see. If you multiply 2B, this means 2. This means every entry will be going to multiply with 2. So this means 2 will be here, 2 will be here, 4 will be here, 0 will be here. So 2, 2, 4, 0, as you can see. Indeed, A is equals to 2B. Okay. Now, what about A determinant? A determinant will be quite simple. So multiply these, you will have 0. Multiply these, you will have 8. Now put minus, you will have minus of it, as you can see. What about B matrix determinant? So this will be multiply this, you will have 0. Multiply these entries, you will have 2. Put minus sign, you will have minus 2. Okay, you will be seeing some interesting properties. What, as you saw that A is equals to 2B, and if you try to see that what happened, that if you multiply this minus 2 with what, 4, and this 4 is just nothing, 2 square, 2 square. Yes, and this 2 square is just nothing. This 2 number will be here, and this number will be what, the order of the matrix, which is 2 cross 2. So 2. That's why we have, as you can see, 4 multiply with minus 8, multiply with minus 2 is equals to minus 8. So in general, what property we are talking about? We are talking about this property. As you can see, if you have what, a determinant, if you are having what, A matrix, which is similar as K times of B. This means scalar scalar multiple of matrix B with K as the scalar. Clear? Now, if this matrix order, this B matrix is order n, okay, obviously the same order will be for A also. Okay. Now the determinant of A will be same as K power n, the determinants of this thing. This will be your final answer in such questions. Okay, please do remember this result. Very important. Very, very, very important. Okay. Now let us move to next. Now what? So we have to evaluate this. So quickly just evaluate this. So as you can see, so I'll be doing in this question with two different approaches. One using wherever we are having maximum zeros in column 3, and I will be using also the normal or the row 1 approach. Okay. So let me just first of all do it by row 1. So plus minus plus, these will be the signs. So plus 1 minus 2 plus 4. Simple. Now choosing this, eliminate these. So eliminating these, I will be using this. So you will only left with, so 0 0, you will only left with 0. So this will be 0. Okay, simple. Okay, now what I will choose next? 2, this 2. So choosing this 2, I will eliminate this one and this one. So I will only left with this. So this entry will be multiplied with this, means 0. This entry will be multiplied with this, means 0. Minus 0 minus 0 0, eliminated. Simple. Now choose this 4, eliminate these entries. You will only left with this. So minus 1 multiply with this 4 multiply with 3 will be 12. You will have this. So this means minus 13 multiply with 4. You will have what? 2 4 5 minus 52. Okay, clear? Simple. Now we will be seeing the row approach, sorry, the column approach. So this column, okay, this will be, as you can see, 2 3. So okay, 2 3, 2 3 means even, sorry, odd. So this the entries will be minus plus minus. As you can see, this entry will be what? 2, sorry, 1 3. Okay, sorry for that. This entry will be 1 3 means even, means plus. This will be minus, this will be plus. This will be 2 3 means odd, 2 3 odd. This will be 3 3 even, as you can see. Okay, so you have to just find the only one sign and then you can place your alternate signs. Okay, now what? Just expand it. So choose this, eliminate all. So you will have plus 4 0 0. These entries will be directly eliminated. You only left with this thing. So remove these. You will have multiply with this, minus 1 minus of 12. As you can see, this will be minus 13 multiply with 4. You will have the same answer as this. By using this approach, the expanding along with C3, you saw that how quickly you got your answer comparatively. Okay, simple. So please do choose your efficient way. Okay, whenever you see the maximum zeros, please do prefer that row or that column. Okay, I hope that it is clear. Now let us move to the next problem quickly. Let us see. So for this, as you can see, we do not have maximum number of 0 in a given specific row or column. As you can see, every row and every column having only one what? 0. So you can choose whatever approach you want. I am choosing this approach, the row 1 approach. Okay, so this means plus minus plus. Okay, so 0 minus sine alpha and minus, so plus of minus cos alpha. This will, I will be directly using minus of cos alpha. Okay, this will directly be eliminated. Now this will be what? Choosing this, and this will be 0. Now multiply with this, means 0. Now minus of cos alpha sine beta, cos alpha sine beta, cos alpha sine beta. This minus and this minus give me plus. Okay, plus. Now clear? Now what about this? This and this will give me these entries. So multiplying these entry will be minus minus will be plus. So sine alpha sine beta, this will be multiplied, this means 0. Okay, now as you can see, you will have a sine alpha cos alpha sine beta minus sine alpha cos alpha sine beta. This means 0. As you can see, sine alpha cos alpha sine beta, sine alpha cos alpha sine beta means 0. You will have what? Your answer as 0. Okay, so the determinant will be 0. Simple. Now, so if this determinant is the same as this, you have to find the x. Okay, so we have to evaluate the determinant quickly. We will evaluate. So this will be 3. This will be minus x square. This is the same as 3. This will be minus of 8. So minus of 8, this means minus 5. Now evaluate. So x square will be, as you can see, 3 plus 5 means 8. This means x will be plus minus, x is equals to plus minus 2 root 2. Yes, x will be plus minus 2 root 2, or in other words, root of 8. Or in other words, what? What you can say? In other words, 2 root 2. Okay, 2 root. But as you saw that you cannot have two different numbers. You cannot have two different numbers. Yes, you cannot have two different numbers. You must be having unique. Okay, you must be having a unique number. So we will see that what number we can prefer. So as you can see, so this 3, if you pick just what? If you pick a root 8, this means we root 8, root 8. Okay, clear? So you will have what? The x can work what? If you use this root 8, then it will be good. Okay, this will happen. And if you pick minus of this, then this will be good. Okay. Okay, this does not what? It does not contradicting anything. Okay, so the determinant of this is just this thing. The determinant of this is unique, already unique. But if you solve this, the value for x, you will have two different values such that it will be satisfied. Okay. Okay, clear? This is not contradicting anything. The uniqueness of the association. Okay, so that's it for now. I hope that you understood everything, how we evaluated our determinant, how we defined our determinants. Please do remember every important remarks. So that's it for now. We will be back with the exercise and the theory part of this chapter, determinants. Okay, I hope that you enjoyed it. So again, thank you.